Good morning, guys. All right, we're getting to the pointy end of this topic. You've done the hardest part so far, okay? Now we're using all of the things we've done and analysing a little bit further with what we call interpolation and extrapolation. The idea is, okay, and pause the video, copy these down, but we have interpolation is using our line of best fit to predict values within that set of data, okay, within that range, all right, that we've either been given or they've told us in some way. Then extrapolation is predicting values outside of the data range set. A good example of this in terms of right now, again, think about all those graphs you've been seeing for the coronavirus. Now they are exponentials, where we're only really dealing with the linear regressions. However, if they look at, say, day zero of, let's talk about just Australia's cases, day zero of Australia's cases, and they've plotted those all along, all the way up to today. I don't know what day exactly it is, but today's amount of cases, right? So let's say the amount of people diagnosed with coronavirus. And they've put this, let's say instead of days on our independent variable, they did weeks, because we're face the fact it's been a few weeks now. So let's say that they've done this graph. Let's say I've got it over here, and they've got weeks down the bottom here, and they've got number of cases up the top as our dependent variable. So we've got week 1, 2, 3, 4. Let's say we're up to, I don't know, but let's say coronavirus has been in Australia for 5 weeks now. Roughly, the graph looks like this. We had from 0, we did have 0 at one case, so we can start at 0, and it's gone up. So there's our exponential. Now, the idea is interpolation is if they said, okay, what do we reckon predict it was at, say, 2 and a bit weeks. So let's say this was in the second week, the Thursday of the second week. They would look at this and they go, oh, yep, okay, there, whatever number is here would be our prediction. That is interpolation, because we're looking at within our set of data, we're either estimating or predicting what that would have been on that day. Extrapolation, though, is if they said, okay, well, let's think, I want to look further than this. Let's look at next week. What's it going to be? And they would go, okay, continue this up. We're looking at about here, and whatever the number on our axis here would be our answer. So hopefully that's a good idea, a good explanation of the difference between your interpolation and extrapolation, okay? Internal, external is the best way to think about that. And great, because they're using this every day, okay? This maths that we are learning right now, they are using this. It's on the news everywhere. The only thing that's different is obviously it's an exponential curve rather than we're looking solely at straight lines. Okay, so just the example I wanted to look at today is we've got an equation that relates a player's height to the number of hoops scored in the game. Okay, so some mathematician worked out that this is pretty accurate only between the heights of 180 and 96. Now, we don't need to know why. We're not wondering about the science behind it. We're just looking at the maths, okay? Some mathematician has decided that this formula here can give you how many hoops they will score on average in a game if you know their height. But it only works, apparently, between the heights of 180 and 196. Okay, so here's our formula. Question A says, well, what is the number of hoops to the nearest whole number scored for a person who is 185 centimeters tall? So really straightforward, okay? You're just going to sub it in. 0.34 timesing by his height, and then we have to minus 61.62, okay? All right. We get an answer of 1.28. Now we think, okay, hang on, wait. Number of hoops scored. You can't score 0.28 of a hoop, right? That's why it says to the nearest whole number, and to the nearest whole number we say therefore one hoop. So somebody who is 185 centimeters tall will get 1 hoop scored during that game. Then it says, is this interpolation or extrapolation? And it's pretty straightforward. It's just a matter of going, okay, well, 185, they said this works if it's between 180 and 196. So then we would say, therefore, it is interpolation, okay? And again, because it's within that data range set. So I've typed it out, and again, if this is my HSC, this is exactly the type of thing I would be writing. So, hang on, sorry, my ruler's out. Okay, so I said, therefore the data is interpolation, as it's within that range specified, and can therefore be assumed an accurate value, okay? So then the idea is with our extrapolation, it's not guaranteed that it's accurate, okay, because we don't really know, okay, what that's going to do outside of our range. Okay, so then B, what is the number of hoops to the nearest whole number if you're 204? So pause the video and give this one a go for me. So there I have it. I've subbed in my value. I got 7.74, which is approximately 8 hoops, okay, they said to the nearest whole number. And I just said, therefore the data is extrapolation, as the measurement lies without, let's done it again, there we go, outside of the given range, and therefore it cannot be a reliable, I could add in there, or accurate value, okay, cannot be assumed a reliable, accurate value would be best. So again, if you're not sure where I got that, 204, oops, anyway, 204, highlighting it, is definitely outside of the range that they gave us, okay? So that was the range that this formula works for. So you could imagine how everything can link together now, and they do touch on it in your exercises where they say, okay, here's the data, now they'll do things like describe the association, find the Pearson's correlation coefficient, draw a line of best fit, then find the least squares regression line of best fit. Now then they'll ask you about your interpolation, then they could ask you about extrapolation. Part C I just added in just to give you a bit of a challenge, I guess, but for you guys I wouldn't even call it a challenge. It says, if John scored 3 hoops, how tall is he? Okay, so this time you're going to sub 3 in where the hoops are. Then you're going to have 0.34 timesing by his height, which we don't know, minus 61.62. So again, this is just going to be an equation. Pause the video, give it a go. Otherwise, for those who have stayed, I'm going to add my I'm going to add my 61.62 to the other side, as it was minusing. Then the last step is going to be 64.62 it'll be, and I'm going to divide by my 0.34, and that will give me his height. 64.62, divide that by 0.34. Alright, his height is 190, and did it say to the nearest centimetre? There we go. So yeah, 190 centimetres. So not a challenge, but could be asked. Alright, exercises for today. Okay, 6E, question 1, 2, 3, 6, 7, 9, 10, 11 written there. Please comment below if you have questions or post it in our Microsoft team. I'm happy for you to also email me, but really your question is probably going to be something that others are wondering as well. Okay, so comment below or post it in Teams.